Good morning. Welcome to Krishna's classroom. I am Krishna Kumar. So we continue with the exploration of the real line or the real number system from where we left in the last lecture. Now you recall we started with natural numbers, that is starting from Peano's axioms, to natural numbers, then to fractions, from fractions to positive rationals, and then to positive real numbers through what is called the Dirichlet's. We have explored the properties of these numbers also. Now I will just put it across in the nutshell what we did, what we have done so far, and how we are going to expand this. So we had a n through what is called Peano's axioms. That defined it. Then we introduced three operations, namely addition, order, and multiplication. We explored the properties with respect to that. Further, we found that the two equations a plus x equal to b, ax equal to b, for ab, comma b belonging to n, may or may not have solutions. Or may not have or may not have that is something of a drawback. Okay. And then we have the concept of nextness. So the concept of nextness. These are the things that we have seen there. Then of course we built up what are called fractions. And then what is called Q plus. Q plus are the positive rationals. We call it positive rationals for the time. But the meaning of the word positive, we are not saying anything about it. But you see that it's a natural extension of n to 2 plus. What do you gain there? Again, it's an extension. You have plus, less than, that's the order relation, and this. That is extension, extended to n plus. Then you see that a plus x equal to b may have a, may or may not have a solution. But ax equal to b for given. Now here we are taking A and B in Q plus term has a unique solution. So that's very interesting. Then there are other properties. There is a unique status for the number 1, etc. And because of this, you see that Q plus is a multiplicative group. Q plus is a multiplicative group. Which is commutative. This is commutative. It's a commutative. Then one more thing is that no nextness. Now this is the greatest casualty. Here you see the transition from our world of our experience, namely something that is discrete, to a new environment, namely something where the concept of nextness fades. It is no more the. And that's a big change, and it's a world of fantasy that you are entering now, a world that we are not very familiar with in our day-to-day experience. Right. So we got Q plus. Now I write it here. You have n containing not equal to rational. Positive rationals. Now we extended this further to, we found that the equations of the type x square equal to x into x equal to a may not have a solution. May not have a solution. More specifically, x square equal to 2 does not have a solution. Okay. So we would like to sort this out if it is possible. Okay. Right? So that's a position that you have with Q plus. Therefore, we made an attempt at this stage to put everything on a line with a 1, 2, 3, etc. This goes up to this, you would mark 1 unit, and so on. Then n equals. These are the natural numbers. So these points correspond to the natural numbers. You have the concept of nextness. Now through Q plus, you have brought in more entities and they are put on the line. Because of the order relation, you can just list them out on this. And that is through usual subdivisions that we make. And then you observe a few things. So now you get a sort of false feeling that every point on this line corresponds to a rational number. And in fact, many mathematicians of that age also thought it is true that once you have rationals, then you have all the numbers, and that is the case. But then to their surprise, they found that square root of 2 is something that can be constructed using ruler and compass. Okay, so that's a different story. That's why the equation x square equal to 2 has no solution here. Now this is the problem. Therefore, one more extension is sought after. There are a lot of problems here. This equation still does not have a solution. At least in some cases, unless it is conditional. That is, the existence of the solution is conditional. Here, of course, this has always a solution. But when it comes to equations like x square equal to a, this may not have a solution. Therefore, we went on to capture these missing elements also, and we got what is called R plus. That is the set of non-negative real numbers. Okay? What did you do? We did two editing first. We devised a way of cutting. Each cut corresponded to a new entity. In fact, you could realize every one of these whole numbers also is a cut. Every one of these rational numbers also is a cut. So, we constructed a world of cuts of this one, and that seemed to, fill the gap. That's what happened. Because in the Q plus, you are seeing that if you are given two rationals, there is always a rational in between. There are infinitely many rationals in between, because you can keep on manufacturing. If P is a rational, Q is a rational, P plus Q by 2 is another rational which lies between P and Q. Okay? So you can do this subdivision, so there are infinitely many rationals in between two given rationals, P less than Q. So that's how you lose that nextness concept. Okay? Just recall that. Now you see, you introduce cuts, because you can introduce a cut everywhere, and you found that there are some nice sets like, this is also a cut. So this you identified with the root 2. The set of all x belonging to 2 plus this set has all the properties of a cut. Okay. But this has no least upper bound, nor the complement of this has no greatest lower bound. That's the important thing. Okay. So, no least upper bound, and the complement of this set of all x belonging to 2 plus the x square greater than even if you put equal to 2, it doesn't matter. Has no least greatest lower. Greatest. Therefore, something that is missing there has been brought. Once you introduce this, then you can show that this set will serve as a greatest lower bound for the complement of this. That's the point. So you capture all such elements using these cuts. Now you can show that this is in a way sort of every bounded subset has a least upper bound. In R plus, every bounded subset has a least upper bound. So the least upper bound property is satisfied. various other ways in which you can prove things like, or you can introduce the notion of what are called Cauchy sequences and show that all Cauchy sequences converge in R plus except for this point. This point we have not introduced. So there are some sequences which do not. Certainly on this side, everything is fine. Okay. So you have this one. Now you see this is a proper extension of Q plus. Addition, multiplication, the order and multiplication can be extended. And still you see that this A plus X equal to B may not have a solution. And AX equal to B has a unique solution. So all these properties are still not sorted out completely. Okay, in R plus. So you see that the R plus is a multiplicative group. There's no problem about it. And it has the least upper bound property. Least upper bound property. All these things are true for this. This is what you have. Now you see you want to go for another extension of this. Okay? And one of the properties that you can prove is the Archimedean property. So this has Archimedean property. So both of them have this so-called Archimedean property. So I just I'm not writing. Now what one does is the following. So you go for the extension. How do you extend this? The first thing that you introduce is a zero element. This is a zero element. Okay. Then what you do is for every psi belonging to R plus, we adjoin an element called minus psi. Therefore, what do you get? You get another class here. Okay. 0 is here. 0 is the one that connects all of them. And corresponding to every psi here, there is an element here, minus psi. And now we have enlarged this class. So you have additionally an element 0. So this is what you get. So let us note this by R defined as the set of all psi belonging to R plus union. There is a new entity called 0, and then adjoined to this the set of all elements minus psi such that for this is your R. You have not brought in any structure yet. Okay.